Alrighty, welcome back. Let's take a look. Let's continue on where we left off. We are going to select our BMask0 and duplicate it, nothing else. Double click on our duplication and rename it up at the top BMask1. Next, we need to add a vector in a texture map, another texture map to our, excuse me, got the hiccups. Texture map in a vector called direction. So we will both animate our texture or animate our normals, but first we're going to add our normals. Yeah. Fumble fingers. Although we have a complete vector up here, X, Y, Z, and W, all we need is two values from it, X and Y, because our UV map, it only has width and height in this case. Alrighty, let's see here, right below here. We'll use the same UV set or the same UV offsets as our main mask. And we are going to pack our normal. Of our normal. So for the moment, that's good enough. Minimize Visual Studio. Oh no. Go back and add a semicolon after direction. Minimize Visual Studio. We can use the same quad. Go to our materials. Checking on OBS here. I hear nothing through my headphones. Okay, so duplicate our BMask1 up here in custom BMask0. Change that to custom BMask1. Shush up. And now we need a normal map. So we're not going to generate a normal map, so I'll be right. Let's just grab. I'll tell you what. I am going to use a plugin on Paint.net. So this is Paint.net, and with it, my other computer just beeped. Hold on. With it, we can, this plugin, you will have to go to if you download Paint.net, you can simply search for it on the internet, Paint.net, get Paint.net is the logo, and then in the forums you will find a normals plugin. We're not going to go over normals in depth right now and how to paint them, but if you want something quick to generate normals, this is a great tool. I'm going to pick a gray and dye that back color with that And now I am going to merge it down. I do not want to save or change the actual texture, so don't save. Now my paint.net keeps on crashing, so I want to save it before I explain it. I have the Windows Store version, so I don't know if that's causing something here. With normal maps, they're normally blue because X, Y, Z, each pixel represents a vertice. That is a normal. A normal is the direction in which we are saying that our wall is pointing. So let's say this is our wall, and we want to say that it's pointing this way. So our pixels RGB will actually represent an XYZ, the rotation of this point, or the direction of this point. So another pixel may be pointing this way. Therefore, unity from its light, that's my sun. If it says this is pointing this way, the more directly opposite and the more negative these are of each other, that means the more they're pointing towards each other, and the more light, whatever color this light is, will be that pixel will be saturated with. This pixel will have less because it's pointing this way. This pixel will have more because it's pointing more direction of our light. And the blue color comes from red, green, blue. Our Z color, our Z, just like in Unity, this is our Z. So if we're standing right here, our Z is pointing towards us. That's why normal maps are normally very blue. We really don't care about what color are they when they're pointing away from us, because we don't see that because they're pointing away from us. So they're normally normalized in between 128 and 255. Red is X, so X would be this rotation. Y is this rotation. Z will also, Z and Y almost rotate the exact same way, because we're actually converting from a 2D to a 3D, or 3D to a 2D space. So if you're trying to create an editor, this will get kind of confusing, but we're not creating an editor right now. This area, this color, is pointing directly towards us. This color is pointing down and to the side, to the right. And if you notice over here, this is pointing down to the left, and you can see the difference in the colors. So red, green, blue. I believe this one this you can see has more red in it. This has more green in it. So red, green, blue. Wikipedia has a great article on this subject. I have actually built a normal editor before, and just for fun, in C# and Windows graphics on Windows Form, but it's actually really important for our stuff here, for our normal maps. Okay, so we want to, for our materials. So just pull our BlendMask1 up there, and you'll notice that we need to tell Unity that this is a normal map. Go back to our quad, and we immediately see definition. So we see what appears to be more faces in our model, like a height map. In this case, it actually appears to be kind of sunk down. You can go back to your normal map. And we can invert our colors just for the heck of it. You've probably seen normal maps like this before. And that kind of confused things, but it is now poking out. Now Unity went through, if you notice, it's still blue over here. Unity actually went through and normalized all the values. So if we tell Unity it's not a normal map, we see our original map. If we tell Unity is a normal map, the values has been stuck between 128 and 255. So don't save my artwork. All right, so, well, I'm not finished here. Hold on, jump over to the other screen. Do this again. I gotta do the whole thing again. But to animate it, we need something to animate, and our straight colors are not going to animate very well. We can see the animation a little bit because this area will be just ripping across here. But I like to do a little bit more. So I am going to, come on. Which color am I animating? That's the wrong color. Let's do green. No, we're going to animate the alpha, aren't we? Yeah. I think we're animating the alpha. Actually, I'm animating all of them. So just, I don't know, put some actually black everywhere. And then we'll put some white in a bunch of places. It's a better tool here. Now put white. Well, that made no sense. Thinking about black, I'm thinking about Curta here and what I need to do. Should be doing this in Curta, I guess. This. Go back and erase all of our black spaces. Just put some erasers everywhere. Erase marks. And now go around and just plop some white spaces down here just to represent now go back over the erase spots and add some black back to it. Don't worry, we'll be working with grass and dirt soon enough. Right now we're just working with this ad hoc texture. I started thinking about that. This probably doesn't look that impressive. Okay, now go back to our normal map, and there we go. We just have spots all over the place. We can see those clearly. Save as. Yeah, save right there. Back to Unity. Now let's go over here and animate everything. Jump down to the bottom, right above our albedo. Float NR0 is equal to, oh, I don't have my animated yet. Hold on. This is the most important part. Well, it's all important. Animated normal. Text 2D. Our bump map again. Our n.uv mask plus our direction times underscore time dot y. We don't need an extra include for time. You can include files in shaders, but we don't need one. Now we come down here. MB. Is that what? Yeah, I'm animating the blue originally. Oh well. So we're animating the blue. And we will just set our normal dot red equal to ng. Our normal dot green is equal to ng0 plus ng1. Our normal dot blue is equal to mb0 plus mb1. Pretty cool, pretty easy. And there you go. It's just trucking along. Now, if it's not trucking along on yours, then you'll need to run your application. Our shader but we really should run it anyway. So select your camera, put its Z at -5, no, -1, and then put its Y at 0. Okay. And then click the play button on Unity. Red, green, blue. So these two both have blue in them, and this one has blue in them. So this one is blue. This one is blue. Okay, excuse me. This one is blue and green. This one's blue, and this one is red and blue. So there you can see them with the actual blue being the most defined because it has the most blue. The red and green actually looks pretty well defined also. But the red, excuse me, the green and the blue looks pretty well defined also. But the red and the green, or the red and the blue, very light, very barely can see it. But animated normals alone has a lot of purpose with fire and water. But in this case, you can see that we are actually not snaking down our path. We're just kind of painting over it, painting behind it so you can see all the edges and stuff. Not really what we want, but it does have a purpose. Animating the normals do have a purpose. Like I said, fire and water, those can be good. Maybe even wind across sand. Footsteps, a monster coming at you that's invisible. That can be a great place for normals, animated normals. But that's about it. Okay, so the next step will be bringing textures into our map and then animating our textures in our normals, or our normals, should I say. And we can actually animate them in two different directions. That produces a cool effect. And then we'll do one more thing where we actually add a fixed light, because if I turn off my light, I have no normals. Normals work totally based on light. What do you do when the lights are off? I mean, we can still see it. We would like to see some definition here, but we can't because there are no normals. That's okay. We have a way to fix that. And we will get to it. See you there.